We also have example number 3 graphed of the function x and the inverse function of x, graphed in the blue, while example 2 is graphed in the red. Now, think about what we did. We switched the x and the y around to find the equations. Well, if you think of what x and y is, it's actually a linear line as well, going through the origin, if I can get it going. So this right here is y equals x. And if you take a look at it, and you take a look at the blues and then the reds, you'll notice that it's a mirror image over the line y equals x. So if I look at the distance between here and here, it's the same as here and here to get to both of the lines. If I look to get to the blue from here to here to here, it's the same distance. It's a nice mirror image. And again, same as you go past here, from here to here, there, it's going to be the same. So that y equals x line is important because that's a line of reflection. So I can really draw the inverse function without actually having the equation based on the line of reflection being this red line right now. So the red line is y equals x, and this purple lines are a function. And if I want to do the inverse function, there's a couple of things I can do. I can take a point off of that, knowing that that's 3, 6, and I can make a point over here, 6, 3, switching them around. And if I know this point, I'll use this one down here, is 0, -6, I have -6, 0 as a point. If I wanted one, you probably want a few to be accurate. So if I have 1, -2, -2, 1 would also be a point. And what you can do then is you just connect those, hopefully a little bit straighter than I do, and you'll notice that they have a reflection off of it. And it should be the same distance between them. Now, some won't be as easy to get the points off. Right here we have a typical cube graph. I kind of switched it around. The y equals x is in purple, and our function is actually the red graph. Now, again, you can pull parts or points off of the graph and use the inverse. But you can also use the graph as a mirror image. You see how right here there's kind of this bump, so I'm going to reflect that bump. And my line doesn't reflect this, but in a typical cube, it reflects over here too. And then it kind of spouts out as this does. Again, though, you can match the points so they're more accurate as you go. But it should give you that mirror image, that distance that's equal on both sides.